Hello, today I'm going to show you how to get your computer to recognize handwritten digits, handwritten numbers. First you want TensorFlow and Python, and I'm not going to show you how to do that. So we're going to make a Python file. So we're going to get the MNIST dataset of handwritten numbers. We're going to we're going to load the data. We're going to create our model. First we need a flatten layer. Flattening a 28 by 28. Then we're going to have a quote-unquote dense layer. With an activation function, and it's going to look like this, basically. That's what the activation function looks like. It goes up like a neuron, because it's a neural network. A dropout layer, so it'll randomly assign some of these connections to not work to help prevent something called overfitting, which can be pretty bad. Then another dense layer for the output, since there are 10 possible numbers it could be. Now we want a loss function, and it's a sparse loss because the data it's comparing it with is going to be a number and not an array. From logits means that the output is not going to be like a probability. It's not going to be quote-unquote normalized, which, I mean, you can try it yourself. If you set it to false, the performance goes down. It goes down a lot. After this, we're going to have we're going to compile our model. We're going to use the atom function, which is like stochastic gradient descent with momentum, and it will increase the learning rate on some of the nodes to make the training faster. We're inputting the loss function, and then metrics will tell us, it just tells us something while it's training and while we're checking to see if the model worked. And now model.fit, this is where we'll finally get to do something with it. It trains the model. We're going to do 5 epochs, because I guess it makes sense, I don't know. Then we evaluate the model, and it tells us the accuracy and stuff on the test set, so we can check for overfitting. And then we have that. But first, before we do that, I'm going to make another function to actually allow us to test our model on individual pieces of the data set. So to test our model, so we get the training, and not training data, we're going to want the testing data. And then this will tell us, this first of all gives us what the model predicts, but it gets it as an array. And then we want the 0 of that array, and then we want the maximum of that to give us the actual number. Then we can and then we get the prediction, the actual, which will be this right here, because that's just how it's set up. And then finally, we can test it out, and then we'll test the model. It's going to test it on the same 4 different values before and after we train it, so we can actually see whether we've made progress. Let's test this out. Let's hope this works. So as you can see, it thinks this 6 is a 3, the 5 is an 8, both 6s were 3s, and the 7 is an 8. So now we're going to be training it. Okay, this is kind of weird. Whatever. And as you can see, the accuracy shot up. That was not on purpose, but oh wait, maybe you can't see. This should be a little better. Right here. And as you can see right here, I'm testing it out. The 6 is correct. 6, 5, 7. So the training actually did something. And that's basically all there is to this. Just going to... Yeah, I guess you could see that. It's okay. Yeah, that's basically it. Neural networks, this is probably not the most necessary. I mean, it's good to know. I'm hoping to, well, you'll see. Probably in a few days. Okay, have a good day. Bye.